Okay, so this is the exam 4 review for Math 114, and for posterity's sake, this is the spring semester of 2024. So if you're watching this video out of sync with the current semester, just know that some of the information might be different. But okay, cool. All right, back to stuff we're doing live. The final exam. I might as well talk about that right now too. You have to take the final exam. It counts towards your grade no matter what. It is the Tuesday of finals week, which I believe is April 23rd. It will be open all day. So it opens up at like 6 a.m. and then it's due by midnight. Our specific time slot is 10 to noon, but you can take it at any point in time you like on Tuesday. It is only one part. So unlike all of our other exams and exam 4 that's about to happen, exam 4 is still 2 parts, one in recitation, one out of recitation. The final exam is only one part, and it's only the out of recitation part. So you do not need to go to any physical location to take the final exam. Take it on D2L from your computer at whatever point in time you'd like. And I will answer that question from chat in a minute. But the first thing I want to discuss is the formula sheet. So for exam 4, here's the formula sheet. It's labeled as practice exam 4 formula sheet right now, but it's exactly the same as on the real exam. And it's this thing that's on screen right now. If you are in a physical recitation, this is the last page of the exam. So it's just printed at the end. Feel free to tear it off right at the beginning of the exam and then just have it in your workspace as you're going through the rest of the exam. If you do tear the formula sheet off, you do not need to turn it back in. It's yours to keep forever, in case you want a memento of your exams in this class. Yeah, formula sheet, you can keep that. If you are in an online recitation where we're not, we can't like hand you an exam packet if you're online, because that's not how the internet works yet. So I've already posted this formula sheet in an announcement on D2L. If you're in an online section, you should just print it off and bring it with you. There will be an electronic copy of this as well, but that tends to be a little bit difficult to read while you're trying to take an exam. So it's easier if you just print it off yourself, but I'll let you decide whether or not you really want to do that. Cool, but yeah, formula sheet, it's right here. Cool, and the first question I saw from chat was, how do you know whether to use the law of sines or the law of cosines? And good question. You are going to want to use the law of cosines if you have a lot of sides, and you're going to want to use the law of sines if you have a lot of angles. Tends to be the delineation. The one case where you have to use law of sines, but you do know a bunch of sides, is if you have repeat information about the same letter. So if I'm looking here at this first example, I've got something about letters A, B, and C, and they're all sides. So I'm going to be using the law of cosines for that one. But if I jump down to the very next example, I have repeat information about letter A. And anytime I've got repeat information about a letter, that means I'm going to need to use the law of sines. So repeat information, repeat letters in the given information is law of sines, and non-repeated information and a lot of sides means use law of cosines. But enough about the pedantic stuff. Let's start this review. Yeah, I've already burned 8 minutes. That makes sense. All right, we'll be coming in with our tires on fire by the end of this review. And even longer if I keep talking about nonsensical things. Okay, so taking a look at this triangle I've got here, I know all 3 sides. So if we're looking for a classification for this triangle, it is a side, side, side triangle. One of the ones that we want to use the law of cosines for. Law of cosines. Since I'm going to be using the law of cosines on this deal, I should solve for my largest angle first. Remember that only one angle inside your triangle can be an obtuse angle, meaning something in the second quadrant. And the only one that's capable of being obtuse is the largest angle. Largest angle is opposite the largest side. So it's going to be angle C. But the reason I want to solve for that first is because if I do have an obtuse angle, cosine inverse is capable of finding that angle. Unlike law of sines or sine inverse cannot find obtuse angles, but cosine inverse can. So I'm going to solve for angle C first, which means I want to set up my law of cosine formula for angle C. So I could just go to the formula sheet and get that. But it is a squared plus b squared minus 2ab cosine of angle C. Because again, we want to solve largest angle first. Just write it. Solve largest angle first. Okay, cool. So I'll rearrange this thing to find angle C. It ought to look like cosine of C is equal to a squared plus b squared minus c squared all over 2ab. If I just divide that over. And then I need to get the cosine inverse of that other side. So C is the cosine inverse or arc cosine. Both are the same function. Don't forget. Start plugging some stuff in. This will be 3.1 squared. You put that information back on screen. 3.1 squared plus 5.2 squared minus 7.3 squared. Right, make sure that the c squared ends up negative in that numerator. The other two are positive, but c squared we had to subtract over to the other side. Divide the whole thing by 2 times the side lengths that are not c. So a and b, 3.1 and 5.2. And throw all that into a calculator. I did that ahead of time. I got 121.1 degrees. C is 121.1 degrees. Cool. So again, I'm solving for my largest angle first, because in the event that I had an obtuse angle, like I did here, 121.1 degrees, that's in the second quadrant, cosine inverse can find that angle for me. Whereas if I tried to solve this with the law of sines later on in the problem, sine inverse cannot find that obtuse angle. It introduces ambiguity into the problem that I don't want to deal with. So I'm just going to solve for angle C first. And then we'll just go down the line and find the others. Let's get angle B next. It's going to be the cosine inverse of, if I just swap some things around here, 3.1 squared minus 5.2 squared plus 7.3 squared, all divided by 2 times 3.1 times 7.3. So I'm using effectively the same formula I had in the step above, the one that I used to get angle C, but I'm changing it around to solve for angle B instead. So whichever angle I'm solving for, that side length gets made negative up in the numerator. That side length squared gets made negative up in the numerator. So when I was solving for C, I was subtracting 7.3 squared, but adding the other two. If I'm solving for angle B, I want to subtract 5.2 squared, but add the other two. And then the denominator is made up of 2 times the product of the sides that are not the letter I'm looking for. The 3.1 and 7.3 go in the denominator for B, whereas it was 3.1 and 5.2 when I was solving for C. As just a quick handy dandy shortcut. But throw that in a calculator and you should hopefully get 37.6 degrees. 37.6 6 degrees. So we got over here. And again, to just answer a quick question, knowing whether I should be using sine or cosine all depends on the classification of triangle I'm working with. This was a side, side, side triangle, so I needed the law of cosines. I can also check back up at the beginning and see that I have none repeat information. I know A, B, and C at the beginning, A, B, and C. In order to use the law of sines, I need to know everything about one letter. I need to know both side and angle for a single letter to use law of sines. If I do not have that, I'll need to go to law of cosines. Hey, what's up? Yeah, so hmm. Gotcha. Okay, so question was, let me start with the part that is going to make sense. Question was, once I know angle C, could I have then gone and used uh, the law of sines to get angle B, since I now know everything about C? And yes, that's totally fine. You can definitely do that. The second half of the question, someone used the law of sines and got a different number. Um, hmm. I mean, it's possible there's a mistake in my calculation here. Anything's possible. Uh, Anybody have a calculator? Want to double check my work here? If you've got it out somewhere. Suppose I could also do the same. Real quick. Or maybe Zoom's already got it. Zoom said they got the same thing I did. Real, hey, don't be like that. Thanks, Gibraltar. I want the arc sine of 5.2 times the sine of 121.1 degrees divided by 7.3. Close my parentheses, type in degrees. I forgot the C in arc sine. Okay, I get effectively the same answer I got with the law of sines, right? I'm off by 0.02. Yeah, that could make sense. But yeah, so again, you could use either law of sines or cosines to get that second angle. And I'm going to move on to getting angle A. We're totally going to come through in time today. All right, angle A here at the end. I know all three angles have to add up to 180 degrees. So when you're finding the third angle, you don't need either the law of sines or the law of cosines. You can always just go to sum of all angles must be 180. So 180 minus 121.1 minus 37.6. You can either do that in your head or use a calculator. 21.3. 21.3 degrees. And then now that I've got all three angles that I was missing at the beginning, we're all done. That's the triangle solved. Brilliant. Okay, so with that done, let's move on to part B of this problem, finding the area of this triangle. And I'm going to solve it out using the new formula that we had from the law of cosine set, because it matches up with the given information that we have. So I want to go find the area. It is equal to, let's try again. Pretty long hat on this guy. It'll be S times S minus A times S minus B times S minus C where S is the semi-perimeter or half the perimeter of the triangle. Let's maybe shrink that down a little bit. Step really isn't necessary, but whatever. All right, so S is 3.1 plus 5.2 blue plus 7.3 all divided by 2, and I got 7.8. So if I'm going to get my area, I just need to plug all that stuff in. So area is the square root of 7.8 times 7.8 minus 3.1, which is 4.7, times 7.8 minus 5.2, which is 2.6. And then finally 7.8 minus 7.3 is 0.5. And throw that all in a calculator and set it up so that it's right next to the answer box. I got 6.90. And we should make sure we put the correct units on this area. I know it should be square units because I'm measuring area. Area is measured in some sort of square distance. So square feet, square meters, square centimeters, something like that. Whereas lengths are all measured in just single length. So feet, meters, or centimeters. If we go back up to the original statement of the problem, all of our lengths were given in feet. So our answer should be in square feet. Square feet. Question from chat. Do we get the area formula on the test? Let's go check the formula sheet. Yep, it's right there. Very last formula on the formula sheet is this area formula. So if you need it on the exam, it'll be there. All formulas that you might need on this exam will be on the formula sheet. So sum and difference, double and half, law of sines and cosines, all 5 area formulas. They're all provided to you. You don't need to memorize any of them for this exam. That'd be kind of a lot. Okay, looking at the next one that we've got. We have a couple of things going on. Also a random wing ding in the middle of the given information, but that's not super important. I've got 2 sides and an angle, which means that this thing is either a side angle side or it's an angle side side triangle. And because I have repeat information in the given, it's not side angle side, it's angle side side. And I've got a few questions. Let me go take this. Hey, what's up? There is also an equation sheet for the final. Yeah, it'll be the same as this. Oh, but wait, the final's open note. So yeah, you can bring whatever formula sheet you want, but I'll also have one. Hi. Gotcha. So I was just getting to that part. We've got the repeat information in the given, or the repeat letter in the given information, which means there's a repeat letter in the classification of the triangle. So S is repeated right away. An angle side or a side angle side or SAS triangle. Since I know side lengths A and C, side angle side would have to be angle B because that's the angle that goes in between them. And since I'm not given the angle that's in between them, the problem's more of a pain in the ass. So we have to use law of sines, and we're going to need to check for 2 triangles. Nice. Correct. And you'll also solve using the law of cosines instead of the law of sines. Yeah, so it's the tricky kinds of triangles are the ones where we know two of the sides instead of two of the angles. Hey. Yeah. Gotcha. Question was, if you have this question, do you have to use this formula, or could you use the area formulas from the law of sines, since we now know the whole triangle? And yes, you could. Though I think this one is only on the unproctored version of the exam. And it's one where I won't ask you to solve for the whole triangle. I'll just give you the three sides and say only find the area. So it'll just make more sense to use this one because you then don't have to solve the whole triangle first. We still could solve the whole triangle and use the other one, and it's totally fine. You don't even need to solve the whole triangle, you just need one angle. But yeah. Cool. We're 1.5 problems done and halfway through our time. We're gonna be on time. This is fine. Okay, cool. So since we had that repeat information, since we have a pain in the ass, we need to check for two triangles. Another easy way to know if you have to check for two triangles, if it's on an exam. If I scroll back up to this problem at the beginning, well, this one says it's 18 points, but I'm also asking you to solve for the area, so that's an extra little bit. This is probably only a 12-point problem if I only say solve the triangle, and then there's 12 points. And then you see another one and it says solve the triangle, but it's 18 points instead. There's more work in an 18-point problem, so that probably means solve for a second triangle. So you can also use the point values to kind of, fudge your way into figuring out how many triangles to solve for. Number of points it's worth will basically just tell you. But I digress. Let's solve this thing out. So I know everything about letter A, which means I'm going to use the law of sines. Law of sines. And I'm going to set whatever I start with equal to the A ratio. I know letter C, so I've got to solve for angle C first. So I'll set this thing up. Sine of C over, let's try again, over 12.8 is equal to the sine of 58 degrees divided by 11.4. And that's going to get me to this equation. Sine of C is equal to 12.8 times the sine of 58 degrees divided by 11.4. And I could just check that number in my calculator real quick. 0.9522. I'm gonna highlight this guy right here. So this number right there is the one that's telling me that I've got two triangles that I need to solve for. Sine of C is equal to a number that's less than 1, which is good because that's where sine is defined. This number were bigger than 1, I'd have none triangles. But it's smaller than 1, so I can solve the thing. There are two angles that are on the unit circle that also could be in a triangle that solve this equation. There is a first quadrant angle and a second quadrant angle. Or in other words, there's an acute angle and an obtuse angle, both of which solve the equation sine of C equals 0.9522. Those are the two angles that we need to start with when we say there are two triangles in this problem. So the first of which I can just get by taking the arc sine of that number. So I'll say C1 is the sine inverse of everything on that other side. 12.8 times the sine of 58 degrees over 11.4. And I got 72.2 degrees. So that's angle C1. The other option for C the other option, call it C2. It's the supplement to C1. So just 180 minus 72.2. Well, let's just call it in general. C2 is just 180 minus C1, or 180 minus 72.2, which is 107.8. So those are my two starting points for the two different triangles. I'll have to use the given information along with whichever label of C I've got to solve the remaining pieces. So I still need to learn everything about B. So let's just focus on angle or triangle 1 to start us off. So B1, big angle B1. I know that all three angles have to add up to 180, so I'll just do that real quick. 180 minus 58 degrees. That's given, that 58, so that's never going to be able to change. Subtract from that as well the 72.2 and get an answer. I've got 49.8. 49.8 degrees. Right. And the last step, solve for angle or for side B1. Probably still easiest to use the law of sines here. So I'll say B1 over the sine of 49.8. And I'll set it back to equal to the given information, which was A, 11.4 over sine of 58 degrees. Solve that thing for B1, which just means multiplying my sine over to the other side. Try that again. 11.4 times the sine of angle B, 49.8 degrees, divided by sine of 58 degrees. And I got 10.3. Once again, I want to make sure that I've got the correct units going on here. If I scroll back up to the top, I'll see that I was measuring my lengths in meters this time, so that should be 10.3 meters. Back to our given information. Both A and C, top of the screen, given in meters. So I want to make sure I use those units. So now let's solve the second triangle. I already got the first angle, so I just started with that all at once. Talking about where those two first angles come from. That's really the hard part of these problems, is getting the first two angles. The rest just kind of fall into place once you start there. So for angle B2, I have to use the given information and angle C2, the one that kind of split my triangle into two parallel dimensions. So 180 minus 58 minus, this time I need 107.8. And hopefully you get 14.2 degrees. So that's angle B2. Side B2. Well, I've already done most of the work. I might even still have this entry in my calculator. Let's try that one more time. So this work right here, that's the work I need for side length B. 11.4 and 58 degrees are all part of the given information. The only thing that's changed is the measure of angle B. So I'm just gonna grab that, paste it up here. I'm looking at 11.4 times the sine of angle B divided by the sine of 58 degrees. But this time, the measure of angle B is 14.2 instead of 49.8. So I'll just swap for the new angle B and plug it into a calculator. I got 3.3 meters. And as a quick aside, because I think it's helpful to, oh no. Well, I don't have it here. Cut that out. As a quick aside, I'll just run over here. Here's the triangle, or the two triangles drawn at the same time, which I'll just bring over to our own version. Copy back to here. Paste. Since I'm running out of time, I won't go through sketching the whole thing. But this is what our pair of triangles look like. I know that this darkened inside, the 12.8. I know that length is given at the beginning. I know angle A, that 58 degrees in the corner, is given. And then I have to drop a side length down of 11.4 from point B down to connect to angle A. But there are two different side lengths I could draw in, two different sides, both with a length of 11.4 that connect down to angle A, which is why I have those two triangles. And then I've just labeled them out C1 and C2. C1 is the acute angle that's part of a larger triangle. And C2, the obtuse angle, but that's part of a smaller triangle. And B1 and B2 are also labeled up there at the top. Hey, they're in the back. And then I'll come up here. Gotcha. So question was, on the exam, will you have to draw this diagram? And no, you won't. Nope. You can if you want to. If you find this helpful and it's easy enough for you to sketch it out, feel free to, throw it together so you can see what's up. But no, this is just meant as a learning guide for you. On the exam, I'll just care about you getting all of the side lengths and angle measures. Yep. No need to sketch the diagram. Hi. Same question. Perfect. Ooh, and let's see what Zoom's got. How do you know where to draw that line down the middle? You talking about the horizontal line down the middle or the two that drop down from the top? Move the chat window out of the way. So for the very first line I draw in a triangle, it's arbitrary. I get to draw it wherever I want to. Once I've drawn the first line in, then everything else needs to be drawn specifically. But once my entire triangle is drawn, I can just rotate the whole thing or move the whole thing in any way that I want to, as long as I'm moving it all together, and it's still the same triangle. So yeah, the very first line I get to draw wherever I want to, because I've got to start from something. And I usually like just drawing a horizontal line. Find it easier to visualize if I just start from a horizontal line. Hi there. Gotcha. Yeah, so the question was, for clarification's sake, that highlighted 0.09 number up on the upper left. If that number is less than 1, you get two triangles. So let me draw that in. And that's correct. Less than 1 means two triangles. Yep. If that number is bigger than 1, you actually have none triangles. Because Gotcha. So you'll know if it's one triangle if that number comes out to exactly 1. Yep. If it's exactly one, you actually have a right triangle, but then it's just back to SOHCAHTOA and Pythagorean theorem. So that won't come up on the exam. Yep. The other version might come up though, the one where there are no triangles. The way that you'll know you have none, even if you don't check that number, when you try to solve for your very first angle, your calculator is going to give you a domain error. If you get a domain error, that means no triangles, or it means you made a mistake plugging things into your calculator. But assuming you did that part right, there are no triangles. 120. Oh boy. Yeah. Okay. All right. Let's take this thing to a word problem. Yeah. I'm going to have to link some extra time at some point. There's my pen. Okay. Cool. So let's take a look at a word problem. I think this word problem uses the law of sines. Okay, so we've got a couple of Coast Guard stations that are going to attempt to locate an aircraft that's been forced to make an emergency landing, an emergency water landing. Cited by the two Coast Guard stations. Conveniently, they're named Brave and Courage, which gives them a B and C label. And what else do we know about them? Brave is 47 kilometers due north of Courage. And then they're going to be trying to locate an airplane. So if I highlight last couple of things, Station Brave can be B, Station Courage can be C, and an airplane can be point A. Works out kind of nice. So what do we have? We've got the bearings that both of the Coast Guard stations are using to locate the aircraft. And we're going to ask the question, how far is that downed airplane from Coast Guard Station Courage? So from the one that's further south. We'll draw a diagram and then label specifically what we're after. But here's what that thing might look like. Bring a ruler out here. So I know that my two Coast Guard stations are due north and south from each other. Courage, point C, is the southernmost Coast Guard station, with Brave being 47 kilometers north of that. Let's give it a label right here, B. And I don't want to put it all the way to the top of the line because I'm going to use that line a little later. Let's maybe move it up to like there. Cool. Things I know. These two stations are 47 kilometers apart. So I'll label that side 47 kilometers. Now I know the bearings from both of these stations to finding the aircraft. Let's see, Brave. I've got a bearing of 57.4 degrees west of north. So I want to go 57.4 degrees to the west. Starting from 90, though, that means that this ruler angle should be about 33 degrees. So put a 33-degree angle on it and measure this line. Cool. So the airplane is somewhere along that line being measured from point B, from my northernmost Coast Guard station. The other one, Courage, it's measuring a 32.1 degree bearing angle. And again, that's west of north. So measure it to the northwest. So again, I'll start from 90 degrees, but this time I'm only going to measure 32 degrees. Well, 32.1 degrees, but I don't have small decimals on here. So 30 degrees would get me to 60 there. Measure another 2 degrees, 58-degree angle that way. And draw in this line right there. So I know that the downed aircraft needs to be on both of those two lines that I just drew. Which means it must be at the intersection of the two lines. So that point right there has got to be A. That's where our airplane is. So ultimately, what were we looking for? We want the distance between A and C, the airplane and Courage. So that is side length B, but it's the one that we're going to solve for. This is the piece I'm really after. So it is part of a solve the triangle problem. I just only need to find one specific element out of the triangle. So labeling the other things that I know, this angle down here by point C is 32.1 degrees. Since that bearing is measured from a north line, right? It's measured from due north, 32 degrees over to the west. And then I also know the bearing angle up at point B. It's 57.4 degrees, but I need to be a little bit careful here because 57.4 is not the measure of angle B. Right, B is the angle that is on the interior of the triangle. So it's really that angle right there. It's the supplement to my bearing. I need to keep that in mind when I'm solving the triangle here in a second. Fortunately, though, for C, the bearing and the measure of angle C line up exactly. So I can just use that 32.1 for C. But to get angle B, I am going to need 180 degrees minus 57.4. And that gets me to where to go? 122.6 degrees. And now that I have B, I can go get A, because A is going to be that angle up there. A just needs to be the difference between 180 and the other two angles. So subtract 32.1, subtract 122.6, and I get 25.3 degrees. And now that I know all three angles, specifically though I needed angle A, but now that I've got all three, I can go figure out that distance. So putting some stuff together, I know this 47-kilometer distance between B and C. That's the measure of length A in terms of the way that I've drawn my triangle. So I'll set up a law of sines ratio. That'll say my distance, B, the one I'm looking for, divided by the sine of B, which is 122.6 degrees, is equal to the ratio that I know, which was A. So that's going to be 47 kilometers on top of my fraction, and the sine of 25.3 degrees on the bottom of my fraction. Just need to solve that equation for length B. And it is 47 times the sine of 122.6 degrees divided by the sine of 25.3 degrees. And that's equal to a number. I get a little cheeky with it. Drag it over to the answer box. 92.7 kilometers. That's the answer I solved for. So a pretty easy variation on this problem, if I were thinking about how to write a test, but minimizing the amount of work I needed to do, might be to just ask you to solve for the distance between Brave and the airplane instead of Courage in the airplane. So effectively just asking you to solve for side length C instead of side length B. just, as a potential heads up on this problem. All right, and that leaves a whole bunch of stuff that we are definitely not going to have time to cover right now. So let's talk about how I do want to cover all of this, because we're done here in a second. So I'm going to pause the recording for a sec. Okay, so to answer a question in chat, what problem should we look for on the exam? Fortunately, the first two we covered are like for sure on first three we covered are like for sure on the exam. There's a solve the triangle with law of cosines. There's a solve the triangle with law of sines. Probably you're gonna have to solve for two of them, just a heads up. So be prepared for that. And then a word problem, probably pretty similar to the one we just did. And there will be a fourth question concerning like probably the half angle formula. Probably like this guy right here, number 7. Put a star by it. I would expect to see like those 3 problems on the exam.